Today on How It's Made. Alligator bags. Lockers. Bench planes. And deployable flight recorders. Alligator bags enjoyed their first wave of popularity at the end of the 19th century. The material was chosen for its exotic look, rich texture, high pliability, and durability. Since then, many legendary designer handbags have been made with alligator skin. For some women, a handbag is more than a practical accessory. It's also a way to express their personal style. Depending on the bag's size, shape, and desired look, many exotic animal skins can be used: alligator, lizard, python, or ostrich. This red skin is from the Nile alligator. The cutter maintains the pattern in place with a weight. He cuts out the shape of the bag, leaving a border, called a turning in, all along the pattern. This skiving machine delicately shaves the back of the alligator skin to make it thin and pliable. A polishing jack creates a sheen. A plating machine applies heat and pressure to remove creases and make the skin shiny. Now it is placed on a hot plate for a few seconds to raise the skin and create what is called French Bombay. They brush rubber cement on the back of the skin and apply it to a thin piece of leather called a pliver. This will keep the Bombay from flattening over time. Then he cuts off the excess skin, creating a turning in. This heavy paper and foam will go inside the bag's cover to give it structure and a cushiony feel. He removes the center part of the paper to help the cover fold easily. He uses a bone folder to fold the turning in over the paper, then carefully hammers it in place. Now he's making the sides, called gussets, and the bottom of the bag. He applies thin muslin and rubs it in place under a protective paper. Both gussets are sewn to the bag's bottom using a very fine needle. The stitches must be as discreet as possible. The bag's lining is made of soft lamb leather called cabretta. The top half contains a magnetic circle, which serves to close the bag. The brand's nameplate is also attached to the lining. The nameplate sits inside the bag, so it will only be visible when the bag is open. The pocketbook maker delicately glues the lining to the bottom of the bag. He folds the leather over with the bone folder and uses the hammer to make the juncture as thin as possible. Since the covers are glued in place, there are no stitches visible on the front and back of the bag, giving it a more luxurious look. Now he scratches the border to remove the sheen, which will help the glue adhere to the leather. He applies the back and front cover to the lining of the bag, making sure all the covers line up perfectly. This step is only performed by experienced pocketbook makers, as it is crucial to the final look of the bag. Anything less than perfect would look like a cheap imitation. Custom-colored paints will fill in any gaps and cover any variation in the leather. They finish by polishing the bag using a small amount of shoe polish and a buffing cloth. They must use very little polish to avoid buildup in the grain of the leather. This also removes any dirt or cement. It takes about 7 hours to make an alligator bag. All the time, effort, and materials result in a stylish fashion accessory that's made to last for years. Lockers are a familiar sight in high school corridors, gym changing rooms, and many workplaces. And in the world of professional sports, lockers are the backdrop to many a post-game interview. The latest trend is buying lockers for kids' bedrooms as cool and practical storage furniture. While they vary in size and design, all lockers have ventilation holes. These help air circulate, which prevents odors. Lockers are made of a hard type of steel that's just flexible enough for presses to bend to the required shape. The steel sheets are 1/10 of an inch thick. Workers feed one at a time through a cutting tool called a square shear. It slices from one end of the sheet to the other, cutting pieces with the required width. Each door piece goes into a 100-ton punch press, which stamps out the ventilation holes. The next press punches screw and rivet holes around the edges, and a hole for the cup that houses the locker's closure. The first bending press simultaneously folds over the top and bottom edges, forming flanges. This bend sets the finished height of the door. The next bend sets the finished width of the door. The press folds the side edges over twice, forming a box-shaped rim. Next, workers position a steel reinforcement panel against the hinge side of the door. They affix one side of the panel using a welding machine that fuses 12 spots simultaneously. Then they weld the other side manually. Now they mount the door in an alignment fixture hinge side up and clamp a piano hinge to the edge. They fuse the hinge to the door by welding it to the top row of screw holes. Meanwhile, they've bent pieces of steel to form the locker's top, bottom, back, and sides. Now they weld those parts together. Then they weld the hasp, the steel loop through which you hook a padlock to lock the locker. The hasp goes on the edge of the body and protrudes through a slot in the closure cup in the door. Next, the locker's interior shelf. They set 4 rivets onto a positioning fixture, 2 in the center, 2 on the edge, then position the shelf on top, aligning the shelf's 4 holes with the 4 rivets. They position a single hook over each edge rivet and weld it on. Then they take a double hook and position it over the 2 center rivets. Then weld that on. Then they weld the shelf into the locker body. All the parts now head into the factory's paint shop. The powder paint they use for this model contains electrically charged silver particles, a natural disinfectant that kills any bacteria, viruses, and fungi on the locker surface. Once coated, the parts go into an oven for a half hour to bake the paint. Then, final assembly begins. First, workers mount the closure cup in the door hole with a screw and a retaining washer. Next, they install magnet catches to hold the door closed. and apply an adhesive sticker indicating this locker has an antimicrobial paint coating. Then they attach the door to the body by driving rivets through the lower row of holes on the piano hinge. They make sure the door moves smoothly and that the hasp aligns with the slot in the cup. The factory makes lockers of various sizes, shapes, and configurations. Some models even have built-in combination locks. Since Roman times, woodworking planes have been part of the carpenter's toolkit. And despite the invention of power tools for wood surfacing, many still prefer the hands-on approach of this simple tool. Using it is a skill that can take a piece of timber from rough to refined. If wood needs shaping, it's time to reach for the bench plane. On the push stroke, it shaves down bumps and high spots on wood to make the surface level and true. Production begins with bench plane patterns. They place several in a box and pour fine sand mixed with a bonding chemical over them. The bonding chemical solidifies the sand. They poke holes to vent gases later on. And with the patterns removed, it's clear that the bonding chemical has worked its magic. The patterns have left a definite impression in the hardened sand. They apply glue to one half of the mold, so it adheres to the half with the impressions in it. They then glue two square-shaped spouts around holes in the sand mold. Next, they fire up the foundry furnace and melt iron into a white-hot liquid. Workers then carefully pour the molten metal down the square spouts and into the sand molds. Gases are released through the holes poked in the sand earlier, while weights keep the lids from lifting from the pressure. After a 2-hour cool-down, they break the molds and pick out the cast iron parts. The planes have a knobby protuberance formed as metal flowed into the mold. They slice that off. And after strengthening the cast iron's physical properties, they mill the bottom of the bench plane to make it reasonably flat. They also expose a slit formed during molding. They now lock the bench plane in position to allow the spike teeth of a cutting wheel to carve into the molded slit. It enlarges the slit to form the mouth of the bench plane, the opening through which the plane's blade will protrude. Some precision work is needed, so a tapered and serrated tool is forced through the mouth. This opens it up a little more to give it the exact dimensions required. Coolant now flows to prevent overheating, as a grinding wheel machines the base of each bench plane until it's completely flat. They now try to slip a very thin steel strip between a level bar and the base of the bench plane. Failure confirms it's perfectly flat. Next, a cutting tool evens a sloped pad molded onto the front of the bench plane. This pad, called the frog, will hold the sliding wedge that sets the angle of the plane blade. Production now focuses on the blade. They heat a steel rod in a furnace until it's white hot and malleable. They then place it under a mechanized hammer, which pounds it until it's flat. They turn the flattened steel sideways, and the pulsating hammer squares the edges. Then another tool stamps the company's insignia onto one end of the blade. The steel rod has been flattened, squared, and stamped. It's then cut to the desired shape and dimensions and given a beveled cutting edge. The next part is called a lever cap, and it will be used to clamp the blade to the bench plane frog. They sand it smooth to improve its look and function. They then buff each part of the bench plane against a cloth wheel to a mirror-like finish. It's now time to fit the bench plane frog into the pad machined especially for it. They secure it with screws. The cutting blade, by now reinforced by a part called the cap iron, fits flush to the frog. They top off the assembly with a lever cap and clamp it all together with the spring system. They fit a knob made of tropical wood on a threaded rod on the front of the bench plane. The knob in the back handle will allow the user to firmly grip the bench plane and push it forward. And with the blade now protruding from the base on an angle, it's ready to level any piece of wood, leaving only shavings in its wake. A flight data recorder, or a black box, records every detail of an aircraft's operations, from engine speed to cabin pressure. After a crash, investigators extract the data to determine what went wrong. Black boxes are actually bright orange, so they'll stand out amid the wreckage. These black boxes are the deployable type, meaning they separate from the aircraft upon impact. This makes them easier for search and rescue crews to recover. To make the outer shell that houses the components, they use a two-part mold, first waxing it to ease extraction later on. Then they brush on an orange-tinted gel coat, a liquid that after 4 hours hardens into a durable waterproof finish. Over the hardened gel coat, they apply pieces of fiberglass cloth, saturating them with orange-tinted resin. They apply extra pieces in the corners for reinforcement. They continue until they've built up 3 layers of fiberglass. The rectangular box on this mold half casts a cavity in the shell that will house the device's key components. They embed aluminum plates within the fiberglass to reinforce the area where screws will attach the cavity cover. A computer-guided milling machine contours a piece of foam that will fit the empty space inside the shell. This foam absorbs the force of impact, so the flight data recorder can survive a crash. They coat one side of the foam core with resin paste, then lay it into the mold. They fill voids with a temporary retaining block to prevent the foam core from collapsing inward during the vacuum process that comes next. They wrap the mold in felt to protect the surface, put it in a plastic bag, attach a hose, then start the suction. Over 4 hours, the vacuum slowly extracts the air, drawing the fiberglass tightly against the foam core without any wrinkles or puckers. It takes another 4 hours for the resin to completely cure. Then they remove the mold from the vacuum bag, coat the other side of the foam core with resin paste, and embed steel reinforcements. Besides absorbing the force of impact, the foam core makes the flight data recorder buoyant should the aircraft go down in a body of water. The device contains 2 antennas, the first of which gets pasted into a designated spot in the foam core. One antenna transmits a distress signal, the other a homing signal to help search and rescue crews locate the downed aircraft. Now they mate the 2 parts of the mold, carefully sliding the antenna that protrudes from one half through and out an opening in the other half. They bolt the mold closed and leave the paste to air cure overnight. The next day, they unbolt the mold and extract the shell, the 2 halves of which are now bonded with the first antenna inside. Now they can install the other components, such as this memory module containing the circuit boards that record the flight data and cockpit audio. All the components prior to installation undergo extensive testing to ensure they operate properly when subjected to vibration and extreme temperatures. The memory module goes into a fireproof box, along with the transmitter that sends out the locating signal via the antennas, the second of which they now install into the component cavity at the top of the box. Then they install the battery that powers the transmitter for 150 hours. They connect the battery to the transmitter in the fireproof box. Connect the transmitter to the antennas. Then screw the cover to the aluminum plates embedded around the cavity's perimeter. The finished device undergoes a series of performance tests. This one, in a special echo-free chamber, verifies the signal the transmitter sends out via the antennas. The chamber's receiving antenna is connected to a computer that analyzes the signal's frequency and transmission pattern, critical factors in recovering the box that provides vital clues for crash investigators. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.